In this question, they're asking us to calculate the indefinite integral of 18x minus 2 over the square root of 9x squared minus 2x plus 13 with respect to x. So to do this, we're going to use the substitution method, and as always, the first step in the substitution method is to decide what we should be substituting in for, or decide what u is. And here we have a few different options. We could choose u to be 18x minus 2. We could choose u to be 9x squared minus 2x plus 13. We could choose u to be the square root of 9x squared minus 2x plus 13. Perhaps we could choose u to be the entire integrand. For us, what we're going to do is we're going to let u equal 9x squared minus 2x plus 13. One hint as to why this might be a good decision is because if we take the derivative of this particular u, we get 18x minus 2, and we have an 18x minus 2 actually in the question. So this is usually a good indication that this is a good choice for u. So let's go ahead and use it. This is going to be the integral of 18x minus 2 divided by the square root of 9x squared minus 2x plus 13 dx. And now if we actually put in our u, we now have, this is going to be the integral of 18x minus 2 all over the square root of u dx. The next step that I'm going to do is I'm just going to replace the square root by exponent. So I'm going to replace the square root by u, or an exponent of 1/2, just because it'll be easier to work with. So I'm not really doing anything here except for rewriting the square root as an exponent. So now I'm in the situation where I have two variables, u and x, inside the integrand, and I'm integrating with respect to x. So we kind of have all these mixed up variables here. So what I want to do instead is I want to get rid of this dx. I want to get everything in terms of u. So what I'm going to do is I'm going to go over on the side here, and I'm going to take the derivative of u with respect to x, which is 18x minus 2. So it's 18x minus 2. And the next step is what I'm going to do is I'm going to pretend this is a fraction. Of course, it's not a fraction, but what I'm going to do is I'm going to pretend it's a fraction and solve for dx. And this will help us solve the problem. Of course, again, this du by dx is not a fraction, but it just so happens that by doing it this way, we actually come out with the right answer. So I'm going to multiply both sides by dx. So du is 18x minus 2 times dx. And then because I'm trying to solve for dx, I'm trying to isolate dx, I'm going to divide both sides by 18x minus 2. And I arrive at dx is 1 over 18x minus 2 du. So now in my integrand, I can just replace the dx by this new version of dx. So it's the integral of 18x minus 2 over u to the power of 1/2. And now this dx becomes 1 over 18x minus 2. 1 over 18x minus 2 times du. And now we can see why this choice of u was a good one, how when we calculate the derivative and having it show up in the question again is a good idea, is because now that this can cancel with this, and now I'm just left with the integral of 1 over u to the 1/2 du. And of course, if I turn this fraction, I can take the u from the bottom to put it on the top by just changing it to a negative 1/2, just by laws of exponents. And now I can actually use my anti-differentiation laws and figure this out. The indefinite integral of u to the power of negative 1/2 is u to the power of, well, I take the negative 1/2 and I raise it by 1, so this becomes u to the 1/2. And then I divide by the new exponent. So the new exponent is 1/2, so I divide by it. And then I add a constant. And so if I take 1 and I divide it by half, I realize that this is just 2. U to the 1/2 plus c. So this 1 over 1/2 is just 2. And now I replace the u with what it actually is standing in for, which is 9x squared minus 2x plus 13. So now we have this is equal to 2 9x squared minus 2x plus 13. 9x squared minus 2x plus 13, all inside of this power to the 1/2. All I've done here is I've replaced u by what it actually is standing in for. And then, if you want, you can replace that 1/2 power of 1/2 to be a square root if you want. You don't have to, but you can. So this becomes 9x squared minus 2x plus 13 inside of square root plus c. And this is the final answer.